You can do stuff with Ktor much more than on the screen, and this is what I'm going to show you a little bit. How many of you have tried Ktor already? Not much. You know Spring very well, you think it's complex, and you haven't tried Ktor. How come? Anyways, let's see. As I mentioned, it's very minimalistic. It has some sort of a life cycle, but it's really minimal one. It's not something that creates beans, services, interfaces, generates proxies, nothing like that. It's mostly something that is composed of the functions, and on the screen you can see a few functions that basically generate the hello world application for you. It's built by the small team at JetBrains, actually not by the Kotlin team. So the Kotlin team is separate, and there is like a few people team, like just a few developers who built Ktor. So it's just an open source project that happened to be built by JetBrains. And let's see what we have in the IDE. So that's basically the demo that I'm going to be showing today. But first, before we start, since not so many of you have tried it, let's start from the basics. Like, how do you create a project with Ktor? What will you see there? What kind of dependencies you get? What's the entry point, and so on. On the website, we have seen like a single function that enters the application, spins up a server, an endpoint, and so on. Let's see what's generated by the project wizard when we create a project for Ktor. So there is a plugin in IntelliJ Ultimate that provides you this wizard, but actually the same you can achieve with the project starter on the web page as well. It's the same logic, it's just the different UI. KDD. So what we have here, we have different options how to generate the project. We can opt in for generating some Git, like initializing the Git repository, package, Ktor version, obviously, and engine. There are multiple engines that can be started within Ktor framework. So most likely you will choose Netty and stick with the default. If you really, really want to create a multi-platform application and compile not only to JVM bytecode but also to native, that's also possible. You would go with CIO. That stands for coroutines IO. That's basically the engine that is developed by the Ktor team specifically for Ktor. Optionally, you can opt in for JD and Tomcat. I don't know why you would do that, but anyways, it's there. And you have options for configuration. The example you can see on the website, since we wanted it like to be a very minimal one, that's why we have it on the website. That one is the default option, like configuring your application with code. But in many cases, you would like to go with the configuration file, the external configuration file, because maybe you want to customize your application. Maybe you want someone else to configure your application and so on. Probably you know why would you use the external configuration file. Anyway, we start with the default option here, and we ask it to generate some samples, right? So whatever option I will choose in the wizard on the next step, for all of them, the wizard will try to generate some sort of a code snippet. And I think this is like the best way to explore the new framework or a new library, because otherwise, what would you do? You would go and read the documentation. Nobody wants to read the documentation. They want the real code in the IDE and start playing with it, right? So this is what we want. Generate some code. And on the second step, there are like plugins or features. I said Ktor is not complex. And usually what you actually need from Ktor is the HTTP, like handling requests and so on. But there are some integrations with other libraries as well that are provided by Ktor, but it's like not a very long list. This is like a common stack. We provide some integration for authentication, handling requests, headers. So let's pick a few features, see the examples, and we get a feel what the framework actually does. So I'm going to select routing, static content, status pages, maybe default headers. No, I'm going to skip that. Let's do call logging, call ID. I'm going to explain in a minute what they are. Like free marker, I want to use like good old free marker, and maybe DSLs for generating, doing server-side rendering, remember. Serialization, and if there are dependent features, like one feature depends on another, the wizard will automatically tell you that, right? For serialization, we need content negotiation feature as well, and maybe WebSockets, right? I just randomly selected a few features, and I just asked the wizard to generate the new project for me. Now we gotta wait for dependencies to download, indexing to finish, and so on. So we can take a coffee or put some water on the laptop to warm it up. Anyways, the project got generated, and whatever IntelliJ is doing here, it's not that important right now. So let's start from exploring the project tree first. Like I'm gonna have to zoom, I think. So what do we have here? Like we have this standard Maven layout, project layout, right? With Kotlin sources, configuration files, some static resources, tests. So there is some support for testing, but let's explore the build file. This is where it all starts. Basically, all those features that have been selecting in the project wizard, they map almost one-to-one to modules, like to artifacts. So you basically get a dependency in your build file. So if you didn't select some feature in the first step, you can always add a dependency here through the package manager and download that. Now, since it's a generated file, and I wasn't doing it by hand, it's hard-coded somewhere in the project wizard, it's using some version that is not up to date, and the IDE immediately tells me that by inspecting the versions and saying like, hey, there is a warning, let's see what it's telling me. So there is an inspection that checks that the transitive dependency of that module has a CVE issue. And so there is some intelligence and some assistance by the tooling for this kind of things, right? This is what we want. We want a coherent experience, like from the beginning till the end, like from generating the project, inspecting the dependencies, all in one place. And like, ideally, I would like to press the button and the application generates itself without me being involved. Maybe the world will become a better place in that case. Anyways, this is what I just wanted to show you briefly. When you generate a project, you get this kind of list of dependencies. The rest is just Gradle. Anyways, so let's explore the entry point. It's familiar, right? You have seen it on the website. There is a function which is an entry point where you basically start the server on some port, and the rest is generated code by the selection of the features that I have chosen in the project wizard. So let's explore. We have added the dependencies to the class path. So we have them in the project file, like in the Gradle dependencies. We have them in the class path, but it doesn't mean that they are enabled. You have to explicitly say that, hey, I want to use this plugin. This is not like in Spring, you have some library in the class path. Spring does class for name and decides whether or not it will work this way or another way without you knowing, right? So you have to enable a plugin if you want to use that. And by you enable that using the install function. So here, status pages feature, so we say, we want to use a plugin, install status pages for me. What status pages mean? Basically, it's like exception handling on the application level. If any of your entry points throws an exception, you decide which one. Something like this, some runtime exception, but it has a type. then for this type of exception, I can have a handler on the application level and decide how do I respond, either with some HTTP status, show some page, whatever, right? And entry point, like the endpoints in the application are, you probably have seen it in the previous presentations. You just can have like get, post, put, whatever. Serving static pages. So it's all simple. It doesn't require me standing here and talking to you about this, right? But let's go further. Configure monitoring. So there is different kind of monitoring that you might want to have in the applications of actually any complexity, whether it's a big monolith or a distributed system, like telemetry, metrics, health checks, whatever, some business metrics of the applications as well. But what I've got here is call logging. So there's a feature called call logging where you can decide how you trace all your user requests, right? And you probably want this call ID of a single request that comes into your system or your application to be either propagated through microservices calls or written into the log file. So, and basically this call ID here, I say, hey, use it as an MDC identifier, and it should be in the logs, right? So I put it into the configuration file. Not me, but it was generated, but anyways, this is how you do it. You can change the name the way you want, you can change the formatting, you can decide that this call ID should be generated somehow. For instance, not use it, like do not take it from the headers, but use some generate function like this. The length should be 10, and please use characters A, B, C, D, E, F, G, H, I, and numbers, whatever. So that's my vocabulary for generating those IDs. Okay, what else do we have here? Templating. So Ktor integrates with quite a few templating engines, the popular ones that we have in Java, FreeMarker, Velocity, Mustache, something else. And also it integrates with HTML, Kotlin X HTML library, where you can write some DSL for generating HTML documents. Server-side rendering people, yeah? Anyways, what else do we have there? Serialization. So to enable serialization, you would actually install content negotiation feature. It's more than just serializing objects into some format and like deserializing it, but you can think of it in this context. Hey, I want to serialize my maps into JSON. This is what I'm going to do. Right? And you can further explore this feature. You know where it is. You can look it up in the documentation. It will be simple to use further for more sophisticated use cases. All right, and sockets. In many projects that I've seen with Ktor, people are actually using WebSockets. For some reason, it's popular. So the demo I'm going to do today is a WebSocket-based web chat. What I want to show here in the generated example is that, okay, you install this feature, and every feature may have also the configuration. So in here, in the Lambda that is passed as a parameter, we actually generate, we configure how it should behave in this specific context. And further on, we define the endpoint. And here, when I was trying and playing yesterday for this demo, I noticed that this one statement is highlighted as yellow. So the inspection tells me that I don't have exhaustiveness check in the in this place, right? So anyone remembers when it happened, like when this feature was added? So in 1.6, it changed. So it should be like, there are two cases how you use when statement, right? You can use it as an expression that returns a value, and you can use it like this without returning a value as a statement. So if there is no exhaustiveness check, like the exhaustiveness is not fulfilled, in this case, it's currently a warning, but in 1.7, in 2 weeks, it's going to become an error, right? So make sure in your applications, if you're using it like this, currently it's yellow. If you ignore it, in 2 weeks, if you upgrade in 1.7, it's going to be an error. You have to fix it, like either add the else branch or add the remaining branches. So just for a heads up for you if you're using it like this. So anyways, that's enough for the starters. Let's see if, did I close the window? Yes, I did. Sorry. How much time do we have? Do we actually have a lot of time for the demo? Yeah, 15 minutes, we can make it. So the web chat and WebSockets. Let's do some fun coding with that. We have a simple project. I'm actually running the older version of Ktor here, but it doesn't matter because this functionality didn't change, and you will find this demo also in GitHub if you find my account. So there is an entry point, and we are going to communicate on this entry path here. Chat. Is it visible for you? Yeah. So we have a user coming into our connecting to our application. Like, is it like a mobile client or something else? A web page, maybe some CLI utility, whatever. And it's going to be a connection. So what do we need to do to keep track of all the users who connect to our application? Obviously, we put them into a list. And whatever connection is created, we put this new user to, that's my cheat sheet here. And so the new connection is created, and connection is actually just a wrapper for the session. Like, what's the session? Like, let's see what's the connection. Sorry, C. Yeah, connection is just a wrapper for the session, so we keep track of it, and we just assign it some generated name, right? And we register that connection in the list of connections, like this. So what's the next step? Come on, people, follow me. Are you developers? By any chance? No? Okay, let's speak in the cheat sheet here. So we have a routing, right? We open up a session. We start communicating over the session. Right? The session has a send function there. So we have to greet the person who connected. So send some message. Welcome to the chat, right? We can tell him like how many users are online and so on, but it doesn't matter. Now the connection is established and we start communicating, like sending messages and receiving the messages. How do you receive a message? Well, via the session. Session? No. There is actually incoming queue of messages in this context, in this WebSocket server session. So we can do receive, but obviously we don't want to do like one receive, we want to do it continuously, right? So how do we do that? Like for this kind of cases, we can iterate over the channels, and that's a suspend call. So it looks like we are writing iterative code, but well, under the hood, Ktor API uses a lot of coroutines magic, and for us it looks like imperative code, but we are actually doing everything asynchronously there. So the frame comes in, the frames In WebSockets, they have different types. They might be text frames, they might be some commands and so on. And we have to check whether or not the frame is actually a text frame, like this. And if it is a text frame, on the next line, the compiler knows it's of this kind of type, and then our frame will actually get an extension function, read text. ArenA, of course, I'm the best typer. So, and this is the message we are going to read from the, no, what did I do? Text. Yeah, so we are receiving some text. Now, wait a second. Yeah, so we received this text. Somehow we probably want to propagate this text further. How do we do that? We can use the outgoing. No, not the outgoing channel, but we need to send it to all the sessions that are in the list. So we're gonna do connections for each, and just it session, session sent. And we're gonna send a message that we received, but add an identifier. Who told you that? Like we probably want to do something like this: val message, C session name. No? Okay, I'm not going to do this live coding. I'm just going to use my cheat sheet. I just don't. It's an early morning, sorry guys. And we don't have time. So I'm going to do this like this. It's the best I can do. I'm not going to use the database right now. So we just compose a message and we just distribute it. What I want you to see here is something else. The code is not that important. It's important what is happening here. On the left-hand side, you can see it's all asynchronous, right? We are actually scaling this service, the single node, with asynchrony to handle a lot of connections, because it's what the service is doing is actually just a lot of I/O. It's sending and receiving messages. It doesn't do much. The only operation it does there is this string concatenation, nothing else. Okay, if we add a database interaction here, like for instance initialize database environment config, I'm going to explain a little bit here. So how do you use Ktor? Normally you implement some sort of a module, and module is just a function, and function is configured in the configuration file. So this external configuration file that is generated when you are using Project Wizard actually generates just this block here for you. The deployment part, the port, you can override it through the system properties, and you can have a list of modules. So you may have a single binary, a single jar that you build, but many different configuration files where you just enable or disable the modules. And those modules are functions, and every function is just an extension function to the Ktor application. So whatever is happening within the scope of this function is happening within the context of the application class, meaning that we will have access to various infrastructure provided by the, by this library, by Ktor itself, and including the configuration. Like if I want to make some custom configuration, like I need for the database, because there is no integration for databases in Ktor out of the box. It's just an HTTP toolkit. So I have to make up my own configuration format. How do I structure the configuration for database connections? And here's how it looks like. So I came up with this thing. Like basically I have a block that is called storage, just made up the name. You can have your own. You can have DB, for instance, or a database. Driver class name, JDBC URL, maybe user, password, whatever. And then, obviously, if it's a custom configuration, then I need to parse it somehow, meaning I need to have a reference to some sort of a configuration object within the application, right? So I pass in this configuration project to my initialization point for the database. That's the function. And all it does, it basically creates a connection, like sets up the Hikari connection pool and starts the connection by using the database class that comes from Exposed library. That's another open source project that is built by JetBrains, again. And okay, so we initialize the database, and whenever you Google for any recipes for using Ktor with databases, or you're looking for some project template, this is what you will basically see, exactly this kind of code, and they are using this DAO pattern, like DAO facade impo. Let's see what's inside. So it's just basically two functions, just a simple example here for you to get familiar with. It uses, it implements the pattern here, the facade, and implements a few business functions where you have the DSL from Exposed library in this case, but otherwise it could be maybe just JDBC, whatever library you use, right? It can be anything. And here, just this function, I just want you to tell, like, this is also like a helper for interacting with the database in asynchronous manner by Exposed. So I'm just using this helper function to run my operations with the database that are going to be non-blocking in my application. What implications it can have? So imagine we add persistence to our application. We receive the message, we send it to the database, like save the message, right? And further on, we send it to the clients. Now in the test, when I'm testing it, so the incoming messages, like receiving the messages from the clients, is asynchronous. Sending the messages to the other clients is asynchronous. Saving to the database is also asynchronous. How do you test it? Like, imagine an integration test right here. So I have it pre-written because it takes time to actually type. You would like, what is the naive way of thinking about this scenario? I would like to send some message to the application that is going to run, and I want to receive the same message from the other side. So if you do it like this, directly with all the asynchrony going on on the server side, you get random results, because the message that you just sent to the application might not have been stored in the database. So between those two events, when you send the message and receive the message, you need to wait for some condition. And the condition is, in our case, it's that the message was sent to the database. We can see it there. For this kind of things, we can use some, we can write some logic, but we can use some libraries as well. So I think this one is very interesting, and hardly anyone knows about it. Awaitility, basically just a single class, but it implements all the DSL. It's a Java library. We can just use it freely in Kotlin applications as well, where you define that, hey, I want to wait at least for 2 seconds and make that many calls every 100 milliseconds maybe to check if the message was in the database. If it's there, we can proceed further and try to receive the messages from the other side, right? And then the application is asynchronous, but testing is kind of synchronous, and we check for the events. Okay, this event happened, this condition is fulfilled, we can proceed further, right? So, did you learn something? Did you, like, how many of you knew about awaitility before? That's a hard name, I cannot pronounce. Okay, not that many. Like, I'm pretty happy that it was useful for many of you. So, Actually, it's not all I could tell you, but we have time constraints. What is interesting is that Ktor, since version 2.0, is multi-platform. So you can compile Ktor project not only to JVM, but also to native. With some constraints, of course. You cannot use Java libraries, but that's just a starter. And my friend, James Ward, I hope he will be talking about this tonight. We were hacking a couple of weeks ago. If it's possible to create a Ktor application that would compile both to JVM with Growl native as well, and pure Kotlin native, and see what kind of benefits we could get there. So the startup time, the binary size, and memory footprint with Kotlin native hello world application is staggering. It's like none, basically none, and a few megabytes, whatever. And even by compiling this application with Growl VM native image, does not give this kind of results, but there is always a cost, right? With Kotlin native, you don't have this huge universe of Java libraries that you can reuse, and with Growl VM you have. So even if you can do a native application, you should ask yourself whether or not you need it, as Hadi said. So with that, I'm going to finish. Thank you for coming, and since you learned something, I'm really happy.